Hello. In this video, we're going to start looking at parent functions and their corresponding graphs. Now, all a parent function is it's the simplest form of a function that retains the overall basic shape of the function that we're looking at. So the first type that we're looking at here is the identity or the linear function. Every line that you've ever graphed has the same basic parent function of y equals x. Notice that the m is 1 and the b is 0. So if it's in mx plus b form, slope of 1, y-intercept of 0 is the parent function. Now, the parent table comes from just plugging these x values in and getting the y value. But notice that if you plug in this -2 into here, that just says y equals -2. So we just get -2 out of that. For the -1, plug it in, you get -1. 0 gives you 0, 1 gives you 1, 2 gives you 2. Notice that the x value is the same as the y value. That's the reason that this is called an identity function. The domain for this is all real numbers, because if you remember, the only things that limit your domain will be rationals and even radicals. As for the actual graph, generally you just plot the points. So -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. And yes, I did just say 2, 2. And now just connect these with a curve, or a straight edge, preferably. That you all have, because you're taking a math class, so you all have a straight edge. Right? Awesome. So there you go. That is the identity function. Next, let's look at the quadratic function. The quadratic function is y equals x squared. And if you plug in the x, you get -2 in parentheses squared. But notice that that -2 is -2 times -2, which gives us a positive 4. Plugging in the -1, we get -1 squared, which means -1 times -1, which gives us 1. Plug in the 0, 0 squared is 0. Plug in the 1, 1 squared is 1. Plug in the 2, 2 squared is 4. Awesome. Notice that when you square something, you always get at least a positive value, or at least a non-negative value. Outstanding. And again, because we don't have a rational or a radical, that's going to give us a domain of all real numbers, -infinity to infinity. Then just plot this, -2, positive 4. -1, 1, 0, 0, 1, 1, 2, 4. And be very careful, don't make this look like this or anything like that. That's just wrong. Don't do that. Also, be careful to try to make this look smooth as much as possible. And connect all these with a curve, and this is the shape of a parabola. All quadratic functions are in the shape of a parabola. Excellent. As for cubic functions, y equals x cubed, just plug these in. -2 cubed means -2 times -2 times -2, which gives us -8, because there were 3 negatives there. Plug in the -1, -1 cubed gives us -1. Plug in the 0, it gives us 0 cubed, which is 0. Plug in the 1, gives us 1 cubed, 1. Plug in the 2, 2 cubed, 8. By the way, be very careful, 2 cubed is not 8. 2 to the 3rd power specifically means 2 times 2 times 2. So that's the same thing as 4 times 2, which gives us 8, which is the reason why 2 cubed is 8, not 6. And again, a domain of all real numbers, -infinity to infinity. Wonderful. And then we graph this. -2, -8. So there are 8 little tick marks on this, and that's going to give us -2, -8 is right down here. -1, -1 is there. 0, 0, 1, 1, 2, 8. And then connect these with a trusty straight edge. Well, not a trusty straight edge, but as smooth as possible. How about that? Let's see if I can do that any smoother. Nope. Nope. Eventually I'll get something that's decent. There you go. Close enough. Oh, I need to continue that just a little bit. There we go. Fantastic. And these are the polynomial parent functions that we'll be dealing with. Y equals x squared, and y equals x cubed. The linear function, the quadratic, and the cubic. We could go on to the fourth power. The fourth power would look very similar to the quadratic, except to be a little bit more sharp here at the edges. Or here, or looking like right here, it'll look a little bit sharper of a kind of a curve there. X to the fifth would be very similar to the x cubed, but again, it would look kind of sharper. And then x to the sixth would be here, a lot sharper than the other two. X to the seventh would be extremely sharp, and so on and so forth. Alrighty, well, I believe I'll go ahead and end it here for this particular video, and I will see you in the next one. Have fun.